Good morning, Logan. What's good? All right, so what we're going to do today is a 3x3 system using Gaussian elimination here. For those of you that don't know, that's just this technique that we're going to be using in class. So remember, our goal is really to get rid of the x's within the first two techniques or steps or styles. I'm going to first focus on those two guys right there. I always use the same exact equations, E1 and E2, and then I'll use E1 and E3. When I notice E1 and E2, I'm looking at the 3 and the 2. If I looked at all the factors, or sorry, the multiples of 3, I go 3, 6, 9, 12, and so forth. And then 2 would go 2, 4, 6, 8. And you'll notice that 6, they both had in common. So that's what I'm going to be using to execute this. So I'm going to be multiplying E1 by 2. So we're going to say 2 times whatever E1 is, and I'll write that out. So we have 2 times 3x, that's going to give us 6x. And then we're going to do 2 times negative 5y, that's negative 10y. And then we have 2 times positive 5z, that's going to give us positive 10z. And then we'll do 2 times 1, and 2 times 1 is 2. All right, so we're going to do the same thing, except this time we're going to be focusing on the front. That includes the entire equation right there. So we're going to multiply by negative 3 this time, so we can get the 6x to cancel. So let's put 3 first and see what happens when we do 3. So when we multiply the second equation by 3, we get 6x. So 3 times 2 is 6, and that's not going to cancel those two guys right there. So I'm going to put an additional negative on it. So now everything's going to get multiplied by negative 3. That'll make that a negative 6. Negative 3 times negative 2 is positive 6y. Then we have negative 3 times 3z. That's negative 9z. And then finally, we have negative 3 times negative 5, and that's negative 15. You'll notice that I kind of say it out loud as I'm going through it. The main purpose of that is so that I don't forget to multiply something or remind myself what I'm multiplying by. I'll even make mistakes as I'm doing it. Next, we'll combine it. This right here is a big fat nothing. I'm not going to write anything there. That's going to give us negative 4y plus z is equal to negative 13. All right, moving on. You know what? I think I made a mistake there. It looks like that negative 5 should have been multiplied by negative 3, giving us positive 15. I'm going to go back and fix that. Sorry. Positive, wow. 15 right there. Line. All right, so that'll give us 17. And then we'll have z and negative 4y. You got to keep an eye out for those lame multiplication errors on accident. All right, now one thing I do next, actually not one thing I do, next I'm going to take a look at E1 and E3. So now I'm going to be focusing on this one and this one, looking at the entire equation, but it's really just the 3x and the 7x. If I look at 3, once again, I go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I went a little bit further than normal. And then if I look at 7, it goes 7, 14, 21, and you're like, oh, there it is, 21. So I'm going to multiply the top equation by 7 to get the 3x to turn into a 21. So we're going to go 3 E1, and we're going to be 3 times the 3x, which is 9. Sorry, that is totally wrong. We're going to go 7 E1. Yeah, sorry about that. 7e1. 7 times 3x is 21x. 7 times negative 5y is negative 35y. 7 times 5z is positive 35z. And 7 times 1, oh no. Oh geez, I'm just making everything ugly up in here. Dun, dun, dun. Oh, we won't need it as much anymore. Let's make sure I don't miss my place. And we were doing 7 times 1, which gives us 7. Sorry about all the fumbles right now. All right, moving on. We now want to take a look at E3. We need to multiply that by 3, but we need to make sure we multiply it by negative so that we do have one positive and one negative. So I'm going to go 3 times 7x. That gives us 21. Negative, though. Negative 21x. Negative 3 times negative y is positive 3y. Negative 3 times 3z is negative 9z. equals, and negative 3 times negative 1 is positive 3. All right, we're going to go ahead and combine those equations together. The 3y and the negative 35y becomes negative 32y. The x's cancel, of course. Plus 26z is equal to 10. All right. Now, part of Gaussian elimination is rewriting your system and showing the reduced system each step. So our first equation is going to stay the same. So we're not going to replace E1 at all. We're going to keep it exactly as it is. Plus 5z is equal to 1. And then over here, when we did the 2E1, 3E2, that's going to replace whatever E2 was. So E2 is now this guy right there. Negative 4y plus z is equal to 17. And then this right here, that's our new E3. So this math, or reduction, is an E3 replacement. So we're going to write negative 32y plus 26z is equal to 10. And that's the first two steps of Gaussian elimination, or some people would say the first step. It's two things, right? You get the blue equation and the green equation. And now what we're going to do is we're going to take the blue equation and the green equation, and we're going to figure out how to eliminate the next variable of y. So once again, I'm going to go 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and then if we listed out 32, and we'd notice that they match there and there. So those are the numbers that match. So we're going to multiply the negative 4 by 8. But we're going to do negative 8 so that we can make it a positive 32 so that it cancels out with that negative 32 in E3. All right, so let's show that. We're going to multiply E2 by 8. But remember, if we multiply by 8, it's going to keep the negative on the 4. So let's do a negative 8 so that we have different signs on those leading coefficients. Talking about those guys right there. All right, so we're going to go negative 8 times negative 4. That's going to give us 32. So we have 32y. Negative 8 times z is negative 8z equals, and then we have negative 8 times 17. I believe that comes out to negative 100 and, let's see, 80 and 56, 136. And then what we'll do is we'll multiply, actually we're not going to multiply anything to E3. We're just going to keep E3 exactly as it is. And I like to put a plus sign just to show that they are being combined. So we'll do negative 32y plus 26z equals 10. All right. Next up, we're going to go ahead and combine these two equations right here, noticing that the 32's cancel, but that only happened because we multiplied that front guy by a negative 8 so that it turned out positive. The z's come out to 17, so we get 7, no, it's completely wrong. I mean to say 18, so we have 18z is equal to negative 126. We want to divide both sides of our equation by 18, now that there's a single variable. And we find out that z is equal to negative 7. Let me think about that for a second. 56 and 70. Perfect. All right. So now what we're going to do is we're going to write, once again, it's Gaussian elimination. So that means you're going to want to keep your first equation, 3x minus 5y plus 5z is equal to 1. You're going to want to write your second equation, which has one less variable because of the row reduction we did in the first step. And then we're going to replace our E3 with this new E3 that we just found, which is z equals negative 7. Now, under the strictest, this works. This right here is all you need to solve it. Now we can use backward substitution. Knowing that z is equal to negative 7, we can grab our E2 equation right here, and we can solve it by saying negative 4y plus that negative 7 we found is equal to 17. And now we have a straightforward linear algebra, just linear equation. Negative 4y equals 24. Divide both sides by -4, and we get y equals -6. Now we're going to take those two answers, right? So we're going to take the two answers, y and z, and we're going to replace them into our E1. And this is going to give us 3y, sorry, my mistake, 3x, minus 5 times that y value, which is -6, plus 5 times that z value, which is -7, and that should equal 1. So we rewrite it, simplify. We got 3x plus 30 minus 35 is equal to 1. To help you guys with that simplifying, 3x minus 5 equals 1. 3x is equal to 6, which means x is equal to 2. We're going to go ahead and write our answer out as an ordered triple. X go first, 2. Y going second, -6. And z going last at -7. And we now have our solution to the system, which actually plugged into any of the original 3 equations will work. Also, if you wanted to plug them into any of the reduced equations, it should also work. There's just not as many variables to plug in, so you wouldn't have to plug in if there was no x. All right, I'll check you guys later. If you have any questions, hit me up. Otherwise, I'll see you on Tuesday.